Hello, my name is Omid Latifi,
My name is Miran Qarachatani.
And my name is Mark Kogan.
and we are excited as Team Escape Velocity to bring you Project Impact. This is a next generation asteroid impact simulation app that visualizes asteroids in a physically interactive 3D manner. It also has mathematically accurate impact visualization based on real NASA and CSA dataset research and formulas. It also includes mitigation strategy visualization as well as defense scenarios. So we're going to start with the Meteor Impact page. And as you can see, all asteroids are rendered in their one-to-one realistic real-life counterparts. And all asteroids are from NASA datasets and they're accurately modeled. And we can also launch our own custom asteroid. This will come in handy later. For now, we can launch the Eros, we can increase its impact speed, and even change its impact angle, all of which have effects on the simulation. Now Mark Kogan will explain the simulation itself.
You're struggling. Now, the Eros impact is about the same size as the dinosaur-killing meteor from 65 million years ago. We can see the real-life verified calculations, including the range of building collapse due to wind blast, seismic effects, thermal effect, crater dimensions, and even potential loss of life. If you land over water, prepare for a tsunami. Here we have a tsunami, we have all of our justifications. If you want to dig further into our reasoning, check the science, and you will see all of our calculations and reasoning that we used. Now, if you want to take things to the next level, create a custom meteor. Choose your material and your size and your impact speed, and results can get pretty crazy. Here, Earth has been destroyed completely and turned into an asteroid belt due to the overwhelming impact energy.
Now here we have the mitigation page. So here you can check out all mitigation strategies that are all evidence-based to either deter or completely eliminate the asteroid impact threats which we viewed in the previous page. So we can either manually deploy them, or we can ask our AI assistant to not only teach us about the various mitigation strategies, but to also deploy them dynamically within the scene. So here we have Impactor 2025, and we can ask our AI assistant to explain and deploy nuclear detonation strategy. And as we can see, it gives us a dynamic explanation, as well as lets us interact with the 3D scene by deploying it in real time. We can also ask it to deploy ion beam shepherd. Spelling is not too important. Our AI model is very smart. It can detect exactly what we're looking for. So here we can see it went from nuclear into ion beam shepherd dynamically. And up next is the scenario page.
So the scenario page will put you in the driver's seat. It's a simulation that simulates you as a decision maker making a decision about a near-Earth object approaching. So when you click Begin Mission, you're approached with a object designation that you can open at NASA, and you can learn more information about it and verify its attributes. This is all the information, and you can dig deeper into the specifics. You can see that there's a required delta V that is needed to change the trajectory of the asteroid, and you need it to change its the direction by 2.5 times the radius of Earth. And the scientist will give you a briefing, and you can go to the mission planning, where you can see the suggested timeline, where this would be the timeline that you need to deploy your solution. And the longer the timeline, the less deviation you need. And you can see the different strategies that you could use with their costs. And each of those different strategies, you can tune the parameters, and you can see each of those diffusion strategies will have their own deviation calculations. And you can say submit, and here it will tell you what exactly went right, and it will give you the probability of success and it will tell you what are the optimal strategies. That has always been. So this dynamic feedback is really valuable in training and making near Earth policy making accessible to people. So this has been our amazing project, Project Impact. Thank you so much for your time.